future. The authors found that after CO2 concentrations peak in the 21st century, by the 31st century, around 40% of the carbon emitted by humans into the atmosphere will still remain. That's to say that around 40% of peak CO2 concentration, on top of the pre-industrial value of around 280 parts per million, will still be around in 1,000 years. So if we were to completely stop emitting carbon today, with a concentration of around 410 parts per million, in the year 3000, the concentration would be around 330 parts per million. This might not sound so bad, but that's if we were to completely stop emitting today and never emit carbon again. A more realistic, if still optimistic scenario is a peak of around 500 parts per million, almost double pre-industrial concentrations, and a 31st century concentration of around 370 parts per million. This means that the impact of carbon emissions persists for longer than that of nuclear waste. After about a century, nuclear waste is roughly 3,000 times less radioactive than it was a year after its discharge from a nuclear power plant. While even after a millennium, the impact of human carbon emissions is reduced by only a factor of 2 or 3. And of course, those increased CO2 concentrations will change the climate in the year 3000. The paper goes on to outline how in the 31st century, the planet will still be nearly as warm as it was when CO2 concentrations were at their peak in the 21st century, how global patterns of rainfall will be significantly altered, leading to massive droughts, and how global average sea levels will have irreversibly risen, but by a highly uncertain amount. In other words, even if we stop emitting carbon today, the climate in 1,000 years has already been altered, notably being hotter. And the longer we keep pumping carbon into the atmosphere before stopping, the worse those effects in the year 3000 are going to be. But in short, climate change is by now locked